Say that we're trying to look through some ordered list of objects. This could be alphabetical, numerical, or even some custom method of ordering that you made up. For our example, imagine that we have a pile of papers with names on them that are in alphabetical order, and we're trying to find the paper with the specific name that we want. How would we do this? One possibility would be to look through papers from top to bottom until we find the one that we want, but this would take too much work. A better way, and one of the most efficient ways of searching, would be using the binary search algorithm. Binary search is a fairly intuitive method that involves dividing up the list in halves. Here's how it works. Say we're looking to find Tristan in this pile. First, we would look at the paper at the middle of the pile, which would be Matt. Since Matt comes before Tristan in the alphabet, we know that Tristan has to be in the second half of the pile. If we start off with 100 papers, now we would only have 50. And we can repeat the same process with our new pile. Say the middle paper is now Yosh. Then we would know that Tristan has to be in the top half, and we've cut our pile down to 25 pages. If we kept going with this process, we would eventually end up with one paper, which is the one we're looking for. Since we kept dividing the pile in half, the number of papers we would have to look at in the worst case is around log base 2 of 100, or 7, which is already better than the 50 average for a complete search. And, if we're lucky, it's possible that we even find it in less time. Note that the larger the pile is, the more efficient the binary search algorithm relative to the other algorithm becomes. If the pile becomes a 1,000 page pile, when performing binary search, we need to use a time of log base 2 of 1000, which is approximately 10 searches, compared to the 500 needed with complete search. With small piles though, this difference becomes almost negligible. For example, with only 10 papers, on average, the difference between using binary search and a normal transversal would only be around 2 searches. However, this is not the only way to use binary search. We could also use it to find where to insert a paper into the pile. In order to do this, we can pretend that Tristan is in the pile and just repeat the same process. Once we end up at the paper that we pretended was in the pile, that is where Tristan would be inserted. Now that we've gone over how binary search works, let's try applying it to a problem. We'll be going over USACO 2016 Silver number 1, counting hay bales. If you would like to try solving the problem on your own, please make sure to pause the video. Here's the problem statement. Farmer John has just arranged his N hay bales at various points along the one-dimensional road running across his farm. To make sure they are spaced out appropriately, please help him answer Q queries, each asking for the number of hay bales within a specific interval along the road. So, if we look at the sample input, the number of hay bales is 4, and the number of queries is 6. The hay bales are located at positions 3, 2, 7, and 5 on the road. For the first query, they ask us to find the number of hay bales between 2 and 3, and we can see that there are 2 hay bales. Alright, so here's how we solve the problem. We first sort the array in increasing order. Now, the index I of a value k tells you how many hay bales there are between 1 and k, excluding k. For each query AB, we can find the answer by taking the number of hay bales between 1 and B and subtracting that by the number of hay bales between 1 and A. Thus, we can just binary search for the indexes of A and B, and then subtract them to get the number of hay bales between A and B. However, this runs into an issue if there is a hay bale on B, since we are failing to count it. To get around this, we can just use B plus 1 so that we also count the hay bale on B. And thus, through a simple application of binary search, we were able to solve the hay bales problem. If you want to see how this algorithm would work on actual code, make sure to check out our website in the description. If you enjoyed our content, please go ahead and like, comment, and subscribe. We hope to see you next time.